In this example, we'll be graphing a piecewise function. In this case, the piecewise function is the absolute value of x, which is defined as being x for x greater than or equal to 0, and negative, or the opposite of x, for x less than 0. If it's helpful for you to write out this function as two separate equations, we can do that. So we can write this as f of x is equal to x for x greater than or equal to 0, and also that f of x is equal to minus x, or the opposite of x, for x less than 0. We can also think of f of x as being y, and if we look at this equation, y equals x, that's going to be a straight line with a slope of 1, which passes through the origin and looks something like this. But this is defined only for x greater than or equal to 0, so we're really concentrating on this portion of the graph. Now, if we look at the second equation, y, or f of x, is equal to minus x, or opposite of x, that's going to be a straight line, and the slope on that line will be negative 1, so this one is falling as it goes from left to right, but also passing through the origin. And this is defined for x less than 0, so it's going to be that portion of the graph. So when we put these two pieces together, we can see in the region where x is less than 0, we've got this falling line, which is in the second quadrant, and it's going to look something like this. And we'll stop that line segment at 0 because this function is defined for x less than 0. If I wanted to, I could put an open circle here to indicate that the point where x is exactly equal to 0 is not included in this line. But for the moment, I'm just going to leave it as is. So next, let's move up to the first equation, y is equal to positive x, and that line segment is defined for x greater than or equal to 0. And so when x is equal to 0, y is 0, and we actually do have a point at the origin, so I can fill that in. And then when x is greater than 0, this line has a slope of positive 1, y equals x. Again, y-intercept at 0. So this line is going to go upwards. And we can see then that the absolute value function looks something like a v. Now, this is a function because if we use the vertical line test, we can see that any vertical line passes through only one point. It never passes through more than one point at any point on the graph. So when we put together piecewise functions, it's very important to look at the domains, or the x values or regions for which it's defined. In this particular example, we can see that the domain, the first function, is defined for x greater than 0. So sometimes when I'm drawing my graph, what I'll do is I will just find those x regions. In this case, x greater than 0 means this region here. And I know that there will be a specific function related to that region. And then for the second portion, the domain is defined for x less than 0. So that's this section over here, x is less than 0, is on this side. When I go back to look at the function, the f of x values for this first domain, I'm seeing that f of x is equal to x, and I can write the equation y is equal to x for that region. And again, I know that the line y equals x will only apply in the domain greater than 0, greater than or equal to 0. When I take a look at the second domain, x is less than 0, that's over here. And the formula that goes with that is the f of x is negative x, or that y is equal to negative x. And the line y is equal to negative x looks like this. It has decreasing slope and goes through the origin, stopping just short of the origin because we have defined the domain for x strictly less than 0. So that means that as the x values increase and get close to 0, we have to stop just short of that point. So we've constructed this piecewise function by putting together two segments, and this function is called a continuous function. That means that we are able to trace it from one end to the other without lifting our pencil. So even though this is two separate segments, they actually join here at the origin. The reason for this is that if we were to actually allow x to be equal to 0 at this point, we would see that -0 is equal to +0, and so they do share a common point here, and the two functions again connect. There are more precise definitions of continuous functions that involve limits, but we won't worry about that until we get to pre-calculus.